This is Dr. Eads again, and the second video is going to be on units and unit conversions. Okay, and this covers chapter 1.1-5 in the textbook. Okay, so first off, quick background on units, right? So there's all sorts of units you can use. We try to stick with SI units. That is the standard in science. So for example, for distance, we like to use meters. So for mass, the official SI unit is the kilogram, not the gram, notice, it's the kilogram. And for time, we're going to be measuring that in seconds. Now, and also there's the standard SI prefixes. One nice thing about the SI system is that the prefixes are based on powers of 10. So these are all the standard milli, kilo, centi, and so on that you're familiar with. So, and of course the other thing in the SI system, so there's base units and there's derived units. So base units, there's actually 7 of them in the SI system, and the meter, the kilogram, and the second are examples of these base units. And then you put together these base units to form your derived units. For example, if you're talking about a speed, speed is measured in meters divided by seconds, or meters per second, so that's a derived unit. And lots of times these derived units get their own special names. So for example, our unit of force is actually a kilogram times a meter divided by a second squared, and we're going to call that a Newton. But we got a couple chapters before we get there. Okay, so now of course there's all sorts of other units out there, so we're going to need to be converting units at times. So in principle, well, we can say the official unit of distance is the meter, but here in the US we typically don't use meters, we use inches or feet or miles or all sorts of other things. So we are going to have to do some conversions. In particular, engineers are notorious for not using SI units, so you guys are going to be stuck with unit conversions. So the key thing to remember that it's all about multiplying by 1. So if you have some particular length, then when you're converting, well, you're not changing the length, you're just putting it in different units, right? And remember, if you multiply by 1, you don't change anything. So that's the key thing to remember. So, and to do this, we're going to write 1 in clever ways. And so you can make use of these conversion factors. There's a lot of these listed in the front cover of your textbook. And the rule for this class is, for problems, quizzes, tests, labs, whatever it is, always use standard SI units unless explicitly instructed otherwise. And the other thing, so this is something called dimensional analysis, always keep track of your units in calculations. It's a good check that you didn't make a mistake. It doesn't guarantee that you got the right answer, but if you end up with the wrong units, it's guaranteed to be wrong. Okay, so first, quick simple example. How many centimeters are in 1.7 meters? So the way I like to write this, so we have our original quantity 1.7 meters. We want to put this in centimeters. So we're going to multiply by a conversion factor, and we're going to write 1 as a ratio of 2 things, and that's going to be our conversion factor. So if we think about the units, well, we want the meters to disappear. So to cancel out the meters, we want meters on the bottom of our conversion factor, and we want to end up with centimeters, so those are going to go on top. So now we want to make this thing in the parentheses equal to 1, so we need to know how many centimeters are in a meter, or how many meters are in a centimeter. So of course there's 2 different ways we could do this. So 100 centimeters is exactly the same as 1 meter, so this is equal to 1. Or if you prefer, you could remember, well, centi stands for 0.01. So 1 centimeter is exactly the same thing as 0.01 meters. Either way works, so you either multiply by 100 or you divide by 100th. But in either case, you wind up with the correct answer of 170 centimeters. And remember, in these SI conversions, remember these are exact numbers. So it's exactly 100 centimeters to exactly 1 meter, so that's not going to impact your sig figs. So there's 2 sig figs that we started with, and so we should have 2 sig figs in our answer. Okay, so a little bit more complicated. So now let's say Alice had to walk across campus this morning, so she walked 1.7 kilometers, and we want that in miles. So we'll set this up in exactly the same way. So we want to start off with 1.7 kilometers. We want to end up in miles, so we need to figure out what the conversion factor should be. If we start off just thinking about the units, we want the kilometers to disappear. So to cancel out the kilometers, we put those in the bottom, in the denominator. So we're going to have miles on top in the numerator. And now we need to know how many miles are there in a kilometer, or vice versa. So, however, if you don't know that, you can always stitch these conversion factors together, right? So remember, these are always equal to 1, so it doesn't matter how many times you multiply by 1, it doesn't change anything. So if you need to have multiple conversion factors to make the units work out, that's perfectly fine. So what I'm actually going to do is I'm going to take kilometers, get rid of the kilometers and convert that to meters. And then the meters, I get rid of the meters with my second conversion factor and end up with miles, because I happen to know how many meters there are in a mile. So if I plug in the numbers to make these conversion factors equal to 1, 1,000 meters is equal to 1 kilometer. Remember, these are exact numbers since these are just based on the SI prefixes, so this doesn't limit your number of sig figs. And then the second conversion factor, I know that 1 mile is equal to 1,609 meters. So now this is not an exact conversion, but this conversion actually has 4 sig figs, so 1,609 meters, but I'm multiplying by my original number with 2 sig figs, so my answer should have 2 sig figs. So 1.7 times 1,000 divided by 1,609 to 2 sig figs is going to leave me with 1.1 miles. Okay, one last example. So again, this is a little more complicated yet. So let's say we were interested in speeds. So the speed limit on Lincoln Highway is 30 miles per hour. And remember, MPH really means miles divided by hours. And we want to convert that to meters per second. Now there's several different ways you could look at this, right? So we could think of it as we're converting miles per hour to meters per second. And well, if you know how many miles per hour are in a meter per second, we could do it just in one step with a single conversion factor. But let's say you don't know what that is. So you can also do the miles and the hours separately. So first off, let's take care of the miles. So I want to get rid of the miles. So my first conversion factor is going to have miles in the denominator, so they cancel out, and meters in the numerator. And then I'm going to have another conversion factor to take care of the time units, so hours into seconds. But note, so the hours started off in the denominator, so to cancel out the hours, I'm going to have hours on the top. So hours in the numerator, seconds in the denominator. So I'm going to have 2 conversion factors, and that's going to take miles to hour to meters per second. I just need to plug in the numbers. So as before, you can look up the conversion. So there are 1,609 meters in 1 mile. And again, that has 4 sig figs, since that's not an exact conversion. So the second conversion factor, well, 1 hour is exactly the same thing as 3,600 seconds. So remember, it's 60 seconds to a minute, 60 minutes to an hour, so 60 times 60, or 3,600 seconds to 1 hour. And this is an exact conversion. Remember, there's exactly 60 seconds in a minute and exactly 60 minutes in an hour. All right, so miles cancels miles, hours cancels hours. I'm left with meters divided by seconds. And then for the numbers, I take 30 times 1,609 divided by 3,600. And when it comes to sig figs, I have, well, 2 sig figs in my initial number, 4 sig figs in the first conversion, well, infinitely precise, so infinite number of sig figs in the second. So my answer should have 2 sig figs, so to 2 sig figs, 13 meters per second.